Okay. All right. So good afternoon, everybody. Welcome to the NAL First Thursday program. Today is February 6th, and it feels like summer has returned to Houston. I'm Lisa Spence, and I'm your hostess for today. Our speaker today is Mr. John Connolly, and I think a lot of you already know him. So John enjoyed a 36-year career at NASA, which included positions such as the NASA Headquarters Exploration Chief Scientist, Altair Lunar Lander Vehicle and Deputy Project Manager, Human Lunar Surface Systems Team Lead, Lunar and Mars Human Mission Design, Astronaut Office Special Assistant, and NASA Headquarters Program Executive. His final role at NASA was in Artemis's Human Lander System Program on loan to SpaceX's Starship Lander project. John's NASA and academic careers have been devoted to leading exploration system design and educating the future workforce that will send human crews beyond low Earth orbit, return them to the moon, and lead them to Mars and beyond. So, after leaving NASA, John decided to share his vast expertise with the next generation of aerospace workforce. He's a professor of practice at Texas A&M University's Aerospace Engineering Department, where he instructs the Senior Aerospace Capstone Design course series and has created and teaches spacecraft and space mission design courses to expand A&M's growing aerospace program. He serves as faculty advisor to the university's AggieSat laboratory. He's principal investigator for the AggieSat 6 mission, which will be launching this September. Is that right, John?
It may slip till December, but it'll be this year sometime.
This year. And he's also the advisor to the Texas A&M Space Institute. His talk today is going to focus on the Texas A&M Space Institute, which will be housed on the JSC property adjacent to the Longhorn pastures. So with that, I am going to turn it over to John.
All right, thank you, Lisa. It's wonderful to see so many familiar faces and names out there on the other side. In some ways, it felt like I never really left NASA coming up here to A&M because I'm surrounded by so many ex-NASA folks. We have 3 different astronauts on our faculty right here in aerospace, and I have Rob Ambrose right down the hall and Nancy Curry and others. And sometimes it feels just like going back to work at JSC. Other times it feels a bit more academic. But I enjoy working with the kids, getting that next generation ready to go. So one of the things that I've been fortunate to be asked to do is to work with the Texas A&M University Space Institute. Any of you who have driven down Saturn Lane, maybe in the last week or two, may notice there's work starting to go on right behind where the Longhorns are, and that will become a construction site here shortly. They're about to move the fence, the JSC fence in to create that 32-acre parcel that will be the site of the A&M Space Institute. And it'll have its own entrance off of Saturn Lane, and then a special entrance in the back for the JSC folks to enter as well. So that was a big deal. It was announced back in November. There was a big groundbreaking ceremony down at JSC with Vanessa and all of the hierarchy of the A&M system down there, and basically you heard all the words from them about what this will be. So I'll get to go into a little more depth for you here, and you'll get to ask questions so that as this building goes up, and it's going to go up pretty fast. Right now, they're just about to start turning dirt over, and the plan is that in about 18 months, that building is going to be standing and hopefully open for use in something on the order of September of next year. So it'll go very quickly. So I got a couple slides here. I'll use those to kind of tell the story as we go on. All right. So first of all, this was a little construction update. We passed the review for the environmental policy. We passed a review from the Texas Historical Commission. We're basically at the 100% design of the building. And right now, I'm leading the trade study for what the materials will be that will go into these planetscapes. We want to replicate a Marscape and a Moonscape, 2.5 acres of each, under a roof in this facility. And so you can see actual groundbreaking should take place any day now. It's somewhat dependent on the city and a few of their things. So Nancy Curry, during the official groundbreaking, planted the A&M Space Institute flag on the back 40 there, and that's about where the Space Institute will be located. So if you think about where the Longhorns are and where the ditch goes across, it goes from the ditch out into the field and then over as far as the antenna range. And so there's about a 32-acre block there. I'll show you a picture of that as it comes up. The building, as it's shown there in that image in the upper right, you can't really get a sense for how big this is. But this is a big, big building, and I'll show you some graphics that illustrate how big it is. But it'll be visible from space probably. Okay. Oh, and there we go. So there's the footprint of the A&M Space Institute. You can see the antenna range. You can see down below where the Longhorn pens are. And so there'll be a big detention pond, which you have to put in Houston anytime you pave anything. And the Space Institute itself is a big. It's something on the order of 5 or 6 acres under cover, and parking in the front, parking in the back, and lots of room to bring experiments and planetary vehicles and everything we want to experiment with on these planetscapes in and out. So you get a sense of scale. So you can see the Saturn V building down here at the bottom. And so that's a pretty big building. And look at the scale of that compared to this building here. It's just gives you an idea of scale. I have another picture here to give you an idea of scale, and they like this up here at A&M. So every one of these scapes can contain a football field. And so if you take the Kyle Field turf, and you could put that inside the one of these scapes with the first 5 or 7 rows of bleachers to boot. So that's about the size of the entire thing. The scapes themselves are about 475 by 225 feet, um, clear span, 80 feet tall, and about 2.5 acres of actual material that we will sculpt to look like the moon and to look like Mars. In between those scapes, okay, so those are the two big parts on the sides. In between those is another building. So this is essentially 3 buildings put next to each other. The moon building, the Mars building, and in between them is another building that contains on the bottom floor, laboratories, which we call garages, because they'll have big roll-up doors that you can roll rovers and things like that right out of them onto these planetscapes. Those garages have mezzanine levels where you could put your workforce who's working on whatever is going on in the garage. So they're kind of office areas, office mezzanines. And then on the top floor, we have an entire floor of project rooms that can be used as workshops or classrooms or offices or any kind of labs you want. So I'll show you that in more detail here in a few slides. But this is the big footprint of the entire building, and you can see there's a 100-foot scale down here at the bottom, just to give you a sense of how big all this is. So we basically have the equivalent of two football fields, one under each side, and this big laboratory section in the middle. So here's some artist concepts of what those will look like. You'll see a lot of pictures here, and then there's a video I'm going to show at the end that's a fly-through of the entire facility. So the Lunarscape, like I said, it's about 2.5 acres. I've done a lot of work on what material we're going to use in here so that it has the correct terramechanical properties, so that when you put a rover on it, the traction, the tractive force and all that is equal to the kind of traction you would get on the moon. When you walk on it in an EVA suit, you have the same characteristics as you walk on it. So we're being very careful about picking a material that gives you the right mechanical properties. Now, it's not going to be a perfect replica of the moon, of course. We're not going to have a vacuum. We can control the lighting very carefully. So on the lunar side, we can light it just in a general way, the way it's shown here. We could light it as earth shine, where you have that bluish sort of lower level earth shine that we've calculated out, how many lumens that puts on the surface. And there'll be another lighting mode for polar conditions where you have a big bank of LED lights that's movable around the perimeter, and you could put that low grazing angle illumination onto the surface. So that's the lunarscape. Notice on the left side of it are those garages I mentioned, and the project rooms above on the third floor. As I mentioned, this is about 80 feet from the surface up to the lights, and we will have machinery available in the facility that we can resculpt any of these scapes any way we want. So imagine that we land back on the south pole of the moon here in the next few years. We take some imagery of what that landing site looks like. We can bring the machines in here and perfectly sculpt that landing site so that we can start imagining what the operations would be in that area and testing things like rovers, EVA systems, and others. On the Mars side, we're doing something similar with trying to find a Mars simulant. That's a little tougher. It turns out Mars has many different surfaces that range from very fine sand all the way to hard rock. And so we're trying to find a general Mars simulant that will give us some good engineering characteristics of the Martian surface. And similarly, like the moon, we will sculpt the Martian surface to have the rock outcrops. We'll probably bring in some some rock materials. So we have rock outcrops all the way down to some of the more level plains that you find in Mars. And just like the moon, we'll have a lighting system that replicates the illumination on Mars as well. Let's see. Down here, you'll see this coming up in the video below. This just shows the side. On the side here, near the garages, you can see the big columns going up. But there's the garages, and there is um, a wormhole that connects the moon and Mars, literally, so that experiments or people or vehicles can traverse from the Mars side of this vehicle of this building to the other side. Not a literal wormhole, but functionally. All right. So here's a cross section of that middle part of the building. So now you're standing with either the moon or Mars off to the left and to the right, and you've cut a section down this long building full of garages and project rooms. So you can see there's these two-story garages on both sides. Okay, one goes out to the Mars side, one goes out to the moon side. They have balconies above for your project team. Um, they have windows, but everything can be closed off. We have some customers talking to us who would like the work that they do kept proprietary, and so there's a way to actually close off these laboratories so others can't see in. Then on the third floor, we have the project rooms going the length of the building, and this very wonderful overlook where you could just look out at either the moon or Mars. To give you an idea what that might look like, there's this picture over on the right. Now, this actually isn't the overlook that runs down the length of the building. This is actually from the auditorium. These are balconies that reach out from the auditorium area. I'll talk about the auditorium in a bit, and that basically stick out into the lunar and Mars areas. They're all glass, so that we could bring the visitors up, and and they could kind of experience what's going on that moonscape or that Marscape through this glassed-in balcony area. So very interesting. One other important thing about this is when we're looking at the lunar and Marscapes, we're going to make them, the surface material we choose is going to be a material that doesn't have some of the bad characteristics, say, of lunar regolith, where you have, all that very, very fine dust that's kicked up and gets attracted to everything. We're looking for materials that will give us the correct mechanical um, mechanical equivalents of lunar soil without all that dust. So we want this to be a shirt sleeve environment and not have dust getting constantly drawn into the air conditioning system and things like that. So we're working very hard to pick the simulants that are the right one. All right, so this now is looking at a plan view of the middle part of that building. And so you have the entry here on the left. There's a large lobby. On the first floor, there's, um, I guess these are garages, but these are garages with display windows in these. So this is where visitors would enter, and you could see perhaps some work going on rovers or spacesuits down here. And these garages, just like all the other ones, have exits directly onto the moon or Marscapes. And then as you step past that, you get into, I guess, what you would call the secure area. So there's a public area, and then there's some security doors. And in the secure area, that's where you have the majority of these 20 garages. And these garages can be, you can omit the partition in the middle and make it a double wide if you want. But you can see the number of individual garages we have available to us. And a lot of these have already been spoken for by companies and organizations around the Bay Area who want a presence in this building. In the back, there's a workroom and the central plant. And then here you see the wormhole going from the moon to Mars. And there's another corridor here that connects them as well. So this would be the entry of the building. So you come in, reception desk. The first two garages that you see have these big display windows for people who want to work on things and don't mind visitors watching. Up above, there's a balcony with all sorts of displays on it, and I'll show you that in a second as well. So that's kind of the grand entrance. This is one of the garages as you walk farther in. And so you can see it's a very big overhead sliding door, overhead track door. And so no center columns or anything like that. You have this large door. You can see the balconies above where you could have, folks working or your project office located. The windows here go into this corridor that goes down the middle of the building. And every one of these garages will be, complete with all the power and usual utilities that you need. If there's anything special, we'll negotiate that with the individual tenants. But you can see it would be quite a place to work. Where if you have a rover or something like that working on it, then you drive it right out onto the planetary surface. As you go up a level, this is the level that contains the mezzanines. So that's these blue areas, these mezzanine office areas that look down on the individual garages below. In the front, we have this mezzanine here that is the exhibit area with the two observation pods that stick out on the mezzanine level into both the Mars and the moon side. Um, and there's some back of the house areas in the back as well. So that's what that mezzanine would look like. The idea here is for it to be a display area and um, have a lot of interesting rotating displays. So that as people come in to tour the building, they can look at the displays, then go into the Mars pod or the lunar pod on the mezzanine, look out at those particular landscapes. So we envision this being a busy building in terms of um, uh, multi-purpose, not only will it have an auditorium, but it'll have a multi-purpose use for celebrations, parties, things like that. And when I get to the auditorium, you'll understand that a little more. Um, this is the corridor that goes down the middle that connects all the garages at the mezzanine level. So this is the collaboration corridor with all its little pods where you can have meetings and traverse the building. Now we get up to the third level, well, which they're calling the second floor plan because the intermediate level is really the mezzanine. And we have these individual project rooms. So there's 18 of them here, and these could be used for laboratories or offices. Imagine if you had a company that wants a presence in the Houston area or at JSC, and you have the opportunity to lease, one of these areas as your Houston base of operations. It would be a heck of a view down onto the moon or Mars from there. And we have had quite a bit of interest from folks who want to do just that. So those are the workshops, the classrooms, the offices, project rooms, whatever you want to use them for on this level. There's a break room here in the back. And then in the front is probably one of the more intriguing spaces in this design. So you get the second level of the observation pods, the observation decks, poking out into Mars and the moon. And there's this large multi-purpose auditorium slash multi-purpose room that takes up the front of this building. And this has us very intrigued by the design that we've been shown by the architects. So you can see that it'll have some fixed seating that will always be there and a large open floor that can be configured with more seats or for celebrations, wedding receptions, you name it. Um, and that's sort of the idea with these large screens displaying either what's going on the lunar Marscapes or displaying whatever the big event of the day is that's going on in space. So as Rob Ambrose would say, imagine this space as the place where people converge to, watch the next humans walking on the moon or to celebrate that crew coming back. It's meant to be a very flexible, multi-purpose space, and we envision it as there being a lot of celebrations happening in this space. So here's sort of a cross section of the project rooms that are above the garages. And this just shows you how you could take these project rooms and you could configure them however a tenant wants. If you need a long, thin one that has a Mars side and a moon side, you can do that. You can stack them side by side. If you want a double project room, if you only need a single one, you can do that as well. So it basically becomes tenant space that any user can arrange however they want. And so here's some images of those project rooms configured in different ways as training rooms or offices or labs or individual offices. Now, this is probably a good point to step back a little bit and talk about the origins of this building. So when the Texas when our senators, Texas state senators, met 2 years ago, they decided to fund to put aside about $350 million towards aerospace, towards making Texas great in aerospace. And 200 million of those dollars were earmarked for a facility for Lunar and Mars simulation and training. And so that was this facility. Another $150 million was earmarked for general research, and that has become the subject of this SEARF proposal call from the state where people have been asked to send in proposals on this $150 million pot of money for space research. So A&M was lucky enough to be asked to be the uh, be the folks who manage the $200 million building, and we're very happy to do that. And very happy that we're working with JSC as part of what JSC envisions to be Exploration Park. So the big empty field behind Building 14 um, is uh, is envisioned to become an industrial park. And so this would be perhaps the first building in that grouping, and probably the biggest. And so we're very happy to be the first. All right. So with that, I'm going to walk you through a bit of and someone's ringing here. I'm going to walk you through a bit of an animation um, of this building. So hopefully this will play um, without any commercials. So there'll be a very nice mural out front. This is entering from Saturn Lane. Um, it will say Texas A&M University Space Institute on it. That's the official name of the facility. So we're going to enter here now on the first level. And first thing you'll see is the reception area as we pass through the glass doors, the mezzanine above with the display areas we talked about. And as you go into the mezzanine, into the little wings on the side, you're immediately presented with that lunar or Marscape in front of you. Incredible view into that 2.5 acre facility. All right, and then pulling back and going back downstairs. These are the two sort of specialized garages that have the windows for the public to view what's going on in those garages. In this case, there's a legacy lunar rover, looks like about ready to take on Mars. And so this is the Marscape on this side. Again, 2.5 acres of Martian simulant that can be pushed into whatever Martian geography we want. It'll have lighting that is correct for Mars, and you can see the 3 levels or 2 levels with a mezzanine of the garages, their mezzanines, and the offices above. Then we go through the wormhole from Mars to the moon, if only it were this easy. And we're now over on the moon side. Same basic configuration of the garages, mezzanine areas, and the project rooms above. But now you have 2.5 acres of the moon underneath you. The lighting on this side, in addition to what I talked about before, we can make this entirely dark, like not see your hand in front of your face dark. And so the idea here is to replicate the conditions on the moon that we have control of in a building like this. So that's the surface, it's the lighting, it's the way it's sculpted to look like the actual surface. And so now we've pulled back. We're up in the corridor that goes through the spine of the building, and you can see down into the garages if the users of those garages want to be seen. Every one of these windows will have blackout features in case there's proprietary work that's going on in them. As we go up to the next level, these are the project rooms. So here's one configured as a classroom. And we're going to scoot out into the corridor where you're overlooking the Marscape in this case. And we're going to go into another one that's configured as an office with a heck of a view, I will add. And then fly through to another one that's configured as a laboratory or work area. And then back out onto the moon on this side. And there in the distance, you could see the little pods that stick out into the moon area, two-story, um, one up on the auditorium level and one on the mezzanine level. And so now we're going into the auditorium, and you can see the artists or the architects' views of what the auditorium might look like. Very large display in the front, fixed seating, and a large open area that can be configured for just about anything. Then on the other side of the auditorium is the Mars overlook, and that's that. All right. So that basically brings us to uh, the end of the material I had. This would probably be a good opportunity to answer a few questions, and I may go back to some of these slides as are needed. So with that, that's the overview. I think I've given you the timeline. It breaks ground literally any day now. You'll see the fences started being moved, the utilities start going in, and things are going to happen quickly. The university chose a design build company, so it's Energy Architects and Vaughn Construction, which are a single company that do design build. They've done a lot of buildings here at A&M and out at our Rullis campus. They build a very, very nice building, and they do it very quickly because they have both the architects and the contractors working together. All right. With that, maybe it would be good to start opening up a couple questions. Let me check out chat here.
Hey, John, I don't see any questions in chat just yet, so thank you so very much for that presentation. But I've got about 2 pages of notes and about 22 questions for you if you're ready. First off, I did drive by the site earlier today, and yes, the bulldozers are quite busy moving dirt and leveling the playing field, so to speak. One of the first things that kind of jumped out to me when you gave sort of the overview, kind of the God's eye view of the entire piece of property. It looked like there was sort of like a tram access way from the other side of the road, from Space Center Houston to this facility. Is that going to be is there a portion of it that will be open to Space Center Houston for their guests?
Yes. So you can see in this image here, we've dotted in tram access because we think Space Center Houston, and we're having discussions with them. It's pretty obvious that they would like this to be one of the feature stops on their tram tour of JSC. So this is dotted in because that would be built by someone else. It's not part of the A&M Space Institute project, but it has already been kind of figured in that that's where you would connect into the tramway.
Okay, great. Yeah, I saw the dotted in and I figured that that's exactly what it was for. You did mention that you know, project rooms could be configured as classrooms. Does Texas A&M plan to do any teaching or student research physically at this facility, or are you looking more to commercialize it for industrial organizations?
Well, so A&M will reserve a few of these rooms for themselves because we don't just want to manage this building. We want to actually use it. I don't think it's been finalized yet exactly how A&M will use the spaces that it reserves for itself. You can do everything that you talked about. You could configure it as classrooms, and it would be just an amazing place, to have a classroom or a laboratory or almost anything. I think all of that is still in work, and so I'm kind of representing Nancy Curry, Greg, and Rob Ambrose here today, and they're really the ones who are negotiating all the leases and all the space utilization for this building. So I know
Perfect.
they have that all in mind.
Okay, great. So a couple of questions from chat. What is the floor size of a high bay, and are they the same for the two high bays?
All right, great question. Um, let's see. So there's kind of a high bay. I'm trying to think what the door height is. That's kind of a key one here. The high bay itself is, on the order of 25 feet um, to the bottom of the structure. I'm trying to remember what the exact floor plan was. I think it comes out to, if I go back to this, that I think a double bay is right about 1,000 square feet. And so I believe, yeah, I'll have to check that number, but that's kind of the rule of thumb I had in mind, that a half sort of high bay was 500 square feet, and a full high bay was either 1,000 or 1,200. And then the project rooms above those would be kind of similar in size because they stack up vertically on top of those.
Okay, I've got another question from my favorite CFD student. If you're not accounting for the dust fineness of lunar regolith, that dust poses specific challenges, would it alter certain data? How would you make up for that in simulation results?
So I think anybody who's looked at lunar simulants knows that there is no one perfect lunar simulant. You can have a perfect chemical simulant or a perfect mechanical simulant, or one that lets you simulate all the traction and terramechanical properties, but you're not going to get everything. So the idea here is we want to put a simulant in these planetscapes that has the most applicability to the big stuff that you're going to test here, and that is rovers, spacesuits, construction equipment, habitats and foundations, landers, landing legs, things that are kind of bigger scale and that interact with the surface, at that kind of scale. If you want to do if you want to do a lot of research um, on the effects of lunar dust on I don't know, bearings, for example, that would be a different simulant. You would choose to do that, and you'd probably have to do that in a controlled box where all that very very fine dust wouldn't you wouldn't get everywhere. The uh, the principle we went in with for this design was we want these scapes to be short sleeve environments where you don't have to put on a bunny suit to use them. If anybody's familiar with the moon dirt box that the folks down at Kennedy Space Center have in the Swamp Works lab, that's a great box of lunar simulant. It has the very fine stuff in it. I think it's the BP1 simulant. But in order to go in there, you have to get fully bunny suited up to operate in there because there's constantly dust in the air. We wanted this to be a short sleeve work surface, non-dust generation. So for things that need to account for the fine dust, I think that's a different facility, or maybe you could put a small facility in one of these garages that works on that particular problem. But in terms of the amount of material we're going to buy and the type of material, we wanted it to be basically dust-free. And by the way, just as a hint of how much material it's going to take to fill these up, we're not talking about buying lunar simulant by the truckload or even by the train car load. We are buying it by the train, complete train load. It will take about 1.5 trains full of lunar simulant to fill up the lunarscape, and about 1 train full of Mars simulant to fill up the Marscape. And one of the instructions we received from the state was this simulant had to come from Texas. So the lunar simulant is coming from a quarry near Uvalde, and we had a hard time finding Mars simulant that was the right color and right texture and had all the right characteristics. So we had to pull out an old map of Texas and look to sort of northeast New Mexico to find the correct material for the Marscape. So it used to be part of Texas. I guess that's as good as we can do.
We'll take it. So there's a question. Pamela would like you to go back and show the slide of the front entry desk and observation garages. Missed that. It went by pretty quickly. If you could just go back to that particular slide in your slide deck and leave it up for just a few seconds, that would be wonderful.
Right. Okay, let's see. Here somewhere. No, maybe not there.
Thought it was kind of towards the beginning.
Yeah, I thought so too. So the front entry desk in this picture is right down here at the bottom, and that's the glass mezzanine up top. I guess that's the
That's
best
the
way.
lobby. Yep, there you go.
Yeah, that's the entry lobby, reception, um, the mezzanine, you know, up above, and these two sort of specialized garages that are meant to, to have interesting things going on in them for the public to view.
Okay, thank you so much. Got another question for you. Will there be a capability to simulate the gravity for relevant operations? And along with that, you spent a bit of time talking about the capabilities for lighting. Are you taking into account anything with respect to thermal properties? So gravity and thermal.
Okay, so you simulate the things you can simulate. So gravity, there are plans for a gravity offload system. That would be something supplied by a user who wants that specific thing. But if you look at the floor plans of the scapes, you will notice, oh, I'm going the wrong way. Oh well. Um, we have kind of left areas in the corners right here to put big pylons up for uh, a large Argos type system, okay, gravity offload system. And so that is a potential thing we could do. It's not part of the initial plan that is going in right now, but the idea of the shape of these scapes and the fact that these corners are kind of left the way they are is so that you can install a gravity offload um, system at the four corners here. So yeah, that is we have thought about that. It's just not part of the facility, the basic facility. Just like it wasn't part of Building 9 when we built Building 9.
Yeah,
The architect's facility came after that.
yeah,
Gotcha.
yeah.
Okay, so
I'm in the
I'm
middle
gonna
of a
Okay, go ahead.
Okay, so that might have been an errant unmute. There's a lot of accolades in the chat. I'll get to those in just a bit. Another question to
I did
create
want to answer the thermal
the
question.
thermal. Gotcha.
So thermal will not be, we don't have solar lamps or anything like that here to replicate the thermal conditions. This will be a short sleeve environment, basically a 75-degree sort of environment. Um, thermal on the moon is very hard to do because depending on the incident angle of the sun, the temperature on any surface has to do more with the incident angle of the sun than with the surface itself. And so that's very hard to do. Mars, of course, is very, very cold. We'd have to have the best air conditioning system in Houston to get down to Mars temperatures. So unfortunately, thermal is one of those things that you have to simulate in some other type of simulation facility.
Okay, so we've got another question for you about how you are going to simulate craters, right?
Yeah, that's a good question. So I was going to uh, put another diagram up here, but you could see on this diagram sort of the idea of craters and a little bit of contouring that goes on here. We actually have a very detailed plan for what we want the moon to look like to start with. And we're working on the contour plan for Mars. And we needed to do that so we could estimate the amount of material we had to buy for these. What I will say about the contouring is we will have a fleet of electric bulldozers and front end loaders and things of that sort as part of the facility that will be able to resculpt any of these scapes in any way we want. The initial design of the lunar scape that I've drawn up has a perfect one-to-one replica of the Apollo 11 landing site on one side of it, and it only takes up about the entire Apollo 11 landing site all the way out to a West Crater only takes up about a quarter of this. Um, but if we had a mock-up of a lunar lander, we could put it there, and we have Apollo 11. And that gives you a mare scape. And then we use the majority of the rest of the area to put some Apollo 16 features that gave you the highlands kind of terrain. And we think that is the kind of terrain we're going to see at the south pole of the moon. So it's a different it tends to be more cratered and um, different than the Mare regions, higher slopes and things like that. So basically, we sculpted this out so that we had kind of Apollo 16 on one side and Apollo 11 on the other side, and that gave us both a Mare scape and a Highland scape. And that's probably the initial one we're going to go with until we land somewhere else, and then we'll push that all aside and we'll sculpt it into whatever the new landing site is.
All right, great. Couple of other questions. A question about whether there were any specific projects or research that affected the initial design of the facility. Was it purpose built for something, or are there features of the building that were purpose built for something very, very specific?
I'd say the building was built generically to accommodate as many users as possible. And so when you purpose build things, sometimes you purpose build things for a narrow user base. And so what we tried to do here was have generic garage areas, generic laboratory areas, generic project rooms, and have these lunar and Marscapes off the side of them. And then the users come in and they may have very specific things they want to do. And this facility is very amenable to, adding very specific things on for different users. For example, gravity offload, someone mentioned. And so it was really meant to be the greatest common denominator of uses that we thought we can put in a building. And some of you may have been part of the series of meetings that Rob Ambrose conducted throughout last year, where he went to the NASA community, he went to the contractor community, he went to the academic community looking for use cases for this facility. And all of those use cases combined became kind of the input deck for how this building was designed. So we're looking for the greatest common denominator of features that people wanted.
Okay, you kind of covered this, but there's a question about the lighting conditions. So if you could kind of refresh us a little bit on the lighting conditions, and then also, is there a role for virtual reality goggles or any kind of sound inputs?
Okay, lighting. So on the lunar side, the idea for lighting is that we have three basic lighting modes. General overall lighting, let's call that lunar noon. And again, we know how intense the lighting is at lunar noon, so we'll size the lights to give you that amount of illumination just as though you're on the moon. There's lunar full Earth shine. So at lunar midnight, when you have a full Earth in the sky, we know the exact color and the number of lumens per square meter that fall on the surface that are reflected from Earth. So that's a very interesting bluish kind of light. So we'll have that, and then the third one will be for the high incident angle or the low incident angle. Um, Lunar polar lighting. So the idea there is to have a portable sun that we can move around on the outside of the lunar scape and provide the correct illumination and the correct shadow angles that we need for whatever the users want for those South Pole conditions. So that's very similar to the kind of things that we do when we go out into the desert and we do desert rats training, and where we carry the big, portable sun with us. And so it's what we're trying to do is we're trying to take all the kind of things we did at the JSC Rock Yard and the kind of things we did in the desert rats training and bring those into a controlled environment where, you don't have to, drag a bunch of tractor trailers full of stuff out into the New Mexico desert or the Arizona desert to do this training. It will all be done here. And so then the users come here to use this, and this will be um, the best simulation capability available anywhere.
All right. And then the second part of that question was about virtual reality goggles and or sound inputs.
So those are sort of specialty questions. One of the things about virtual reality is uh, we're trying to make actual reality here. So the idea here is to give people in rovers or people in spacesuits the actual feel of being on these planets without having to go to a VR kind of system, to give them the actual boots on the ground feel or wheels on the ground feel of what this actually feels like to drive around or walk around or operate in these environments. So I'd say the virtual reality might have more to do with how you communicate that experience to people who are not on the planetscape. Maybe they're the people, watching through a NASA website where you could actually maybe put that capability on the people who are training there and let people basically ride along with the astronauts. As far as sound goes, um, I haven't really thought much about sound. It's going to sound like crunchy gravel, I think, as you drive across this. As you know, the moon has no actual sound, and on Mars it's very high pitched because you have a very, very low atmospheric pressure. So sound really never came into the equation as we were looking at this facility.
All right, great. Thank you for that. I know we're peppering you with a lot of questions that might be just slightly off to the side of your specific bailiwick. And here's one that comes a little bit, there's a lot of I'll say churn. That's a good NASA term. There's a fair amount of churn going on currently with directives coming from the current administration. Have there been any rumblings about changes that might be made to the building or the mission of the Space Institute based on, any of that, anything that's going on that way?
Yeah, not that I'm aware of. This we had a plan for this building and we're proceeding with the original plan as far as I know. And you could ask the guys operating the bulldozers there on Saturn Lane if they've
Go forth and prosper. All right, thank you. So another question, will the facility be used in university classwork curriculum? And if so, what would those classes be? Would students be allowed to travel to Houston for part of their program?
Well, I would certainly hope so. I would hope that some sort of university work goes on here, classroom training. Let's see, which classes? Well, let me think of the classes I teach.
I was going to say I'm available. I'm already teaching some classes, but
Um, yeah, but any classes that have to do with operations or with mechanical design of rovers or design of EVA suits or ISRU or habitats, on the surface. There's lots and lots of stuff that, if you want to actually transfer the classroom knowledge to, the actual surface, there it is. And so I think there's a lot of opportunities for that that are, I don't think we've fully fleshed those out yet.
Okay, so I'm glad that you mentioned habitats. As you were going through the slides, I did see, I believe it was on the Marsscape. It looked like something that was very, very similar to the Hera facility, which is what I was in charge of for a long time. But one of the questions that was posted here is, will months-long analog missions be conducted here? And if so, Stokes wants to know if he can be the sim soup for those.
Stokes, we'd be proud to have you as a sim soup for that. As long as you don't throw too many too many square pegs
Malfunctions.
at the crew. I would certainly hope that this would be the place that you would conduct those long simulations, because not only do you have the acreage literally to put habitats down, but now you have the ability to combine the experience of what goes on inside the habitat with the EVA experience as well, which is very limited, of course, in Hera. And so, yeah, I would say this is Hera squared. This is taking the kind of simulations we've been doing and taking them to the next level.
All right, great. Just a comment about the virtual reality goggles can convey a wider range of electromagnetic spectrum the human eye can see. So suggest looking at VR, not just as artificial reality, but a window into deeper reality. So good comment. Another question, you mentioned the name of the architecture and construction firm. Could you run that past one more time?
Yeah, it's called Energy Architects, and their partner construction is called Vaughn, Vaughn Constructors. They build a lot of stuff in Texas, a lot of academic facilities, a lot of large structures, and so this one didn't scare them at all, even though it is a huge structure.
And you mentioned that they've built some structures at the Rellis campus. Are they involved in the upcoming nuclear reactor facility construction that you're
That's a
aware
good. I am not aware of that.
of? Okay.
I know we're talking about that. I know that they designed and built most of the existing buildings that have been built in the last 5 years out at Rellis. So if you're familiar with the Rellis campus, there's all these beautiful brick buildings with green roofs, very large scale facilities out there. We've built hundreds and hundreds of thousands of square feet of facilities. And basically, it's been energy architects in Vaughan that have made those appear as quickly as they have.
Okay. So another question, I saw in the God's eye view again, you have skylights in the top of the structure, so obviously some kind of natural lighting available. In terms of the infrastructure for the facility itself, is there any solar power or alternative energy production being looked at to power this kind of a facility?
Not that I'm aware of. So you're right. The little cross section I've shown here is the collaboration corridor, and that indeed does have skylights in it to get some natural light down into the facility. But generally, these planetscapes don't want natural light. They want, on the moon, you may want it 100% dark, except for that sun on the horizon. And so the skylights are really more for the project rooms, for the places where people might have offices. For the largest part of the building, though, it's going to probably be artificially illuminated. Um, I'm not aware that they've looked at putting any kind of solar power or anything like that on this facility. So as far as I know, uh, it's
On
kind
the grid?
of standard construction, and it is a very specialized building. So I'm not even sure exactly where it falls in the green, silver, gold kind of
The lead, yeah, lead certification process. So yeah. Um, okay. Let me see if I had any more questions. I'm not seeing any additional questions in the chat. I do want to make sure that for all the people online, if you have a question, this would be an excellent time to either put something in chat or David, can they unmute themselves now?
They can, yes.
Okay, so if you have a question and you'd like to unmute to ask it, go right ahead.
Fire away.
We've probably got you for maybe about another 10 minutes, and then you have to scurry off to go
I have to
teach.
go teach a class, yes.
John, what classes are you teaching?
Thanks for asking, David. I took over the capstone courses here at A&M. So every engineer does a capstone design. And in aerospace, we give them generally either a space or a spacecraft or aircraft kind of design challenge that the students work on all throughout the year, 2 semesters long, and they actually build something at the end. And so we have a number of different projects that they get to choose from that come from NASA, Department of Defense, aircraft manufacturers. We have a bunch of students working on designing better disc golf discs for a disc golf company this time around. So I get to kind of oversee those capstone projects, and I'm basically teaching them the NASA Systems Engineering Handbook in the first semester that we have them, and then the second semester is them doing all this design work as good systems engineers. So I teach that. I also teach a course at Space Mission Design that was very popular the first time I offered it, and I'm writing another course on spacecraft design.
Very cool. Thanks.
Yeah, we did get another question in chat. And it relates to, are there any concerns about noise and specifically noise, sort of ambient noise carrying over into habitat studies or auditorium presentations, things of that nature? Or do you think that the sound insulation has been fairly well taken into account?
So the only connection between the auditorium and the two scapes are the little pods that the mezzanine kind of pods that stick out there, and I believe there are glass doors to enter those. So yeah, there is kind of a barrier noise-wise between them. So if you're trying to get a very quiet lunar scape, you don't want to hear the presentations going on in the auditorium. And I think that's been taken care of. I think they have the right number of turns and bends and things like that.
Okay, great. All right. Any other questions from anybody online?
One question. Have you developed any requirements for the unmanned probes that will precede the manned landings or missions where you'd like them to go look for certain data or certain conditions at the surfaces to improve your facility both for the moon and for missions to the other planets? And do you coordinate with the JPL guys who try and produce similar environments for the unmanned missions? Enough said. Thanks for your patience.
Thanks for the question, Howard. So I think this facility will be the beneficiary of the missions that are going to the moon to kind of scout out the areas for the future human missions. So the lander missions that are being flown by Intuitive Machines from down there in Houston or from Firefly Aerospace up in Austin, both of which will land on the moon about the same time here in the next month. I think the imagery we're going to get from those will influence how we sculpt these areas, because if they find that perfect place to land, we're going to duplicate it here. Now, in terms of talking with the JPL folks, JPL has a Mars yard as well, and they have a more detailed kind of indoor facility where they have the Mars material that's very, very fine, where you do need to mask up to be in that facility. And the indoor facility, both there and the one at Kennedy, is sort of what caused us to think that we want a facility where we don't have to have all that, PPE necessary for people to use this. So we did learn a little bit from that. And then it's the external JPL Mars yard and the external JSC rock yard that were really the models for this. And, we wanted to put that under cover. So we definitely did learn from the experiences of both what's happening at JPL and KSC, and at our own experience in the JSC rock yard to basically do the programming on what we have going on here. But in terms of the missions that fly, they're going to fly hopefully soon. We're going to, we're on the receiving end of that data, and we're going to use it to make the lighting, the the terrain, everything about this as close to the real thing as possible.
Did they take your inputs when they were laying out their requirements, or no, you're just the other way? It's only one way.
Oh, they did. Yeah.
Yeah.
So luckily, Nancy and Rob have had me involved in this from pretty much the beginning. So we've been able to dictate, what the surface is going to look like and how big it's going to be, and how big the hills and the craters have to be from the very beginning. So one of the nice things about being part of a project like this from the very start is that the architects are very responsive to your requirements.
Thank you. Appreciate your patience.
All right, I got about 2 minutes before I got to.
Okay, so we're going to call this last call on questions. One last question: how will A&M avoid being used by Mars advocates to XXX avoid using the moon as? Mark, do you want to finish that thought? It's an incomplete question. Okay, I don't think we're going to get to it. We need to let you go. John, I really appreciate the presentation today. Thank you so much for all this fabulous information, and also the energy and leadership that you've really brought to this program. Can't wait to see this really come to fruition. So I do appreciate your time, and thanks very much. Come and visit us in person when you're down in the area. I do want to remind everybody that the video recording of today's presentation will be on the NAL website in just a couple of days, and that our next first Thursday meeting will be on March 6th. We do plan to be live in the Lone Star Room at the Gilruth, but stay tuned for more information about that program. So again, thank you so very much, and we'll let you sign off.
Thank you,
All right.
John.
Well, it's
Great
great to
one.
see. Great to see so many of you. Over and out, and gig 'em.